invited speaker in many national level workshops. He has published more than 20 research articles in the reputed international journals like IEEE Transactions. And he is also serving as a peer reviewer in many reputed international journals and conferences. He has been an active member of IEEE, Signal Processing Society, and Engineering in Medicine and Biology Society. We are very much delighted to have you, sir, here in AICT RGPV 1 week online teachers training program in applied natural language processing. And this is day 4 afternoon session. So I request you to take over the mic and start with the session.
Okay, thank you, ma'am. Thank you very much for the introduction. Without taking much time, I think we have already lost half an hour. So I'd like to start as quickly as possible,
Yes.
because many things are already lined up. So, okay, let me switch on the video. Yeah, no, so video is on. So let me share my slides, then I will start. Ma'am, this message is saying host disabled participant screen sharing.
Yeah, are you getting, sir?
Ma'am, it's not allowing me to share my screen.
No, we have already given you the rights. Please check once.
Okay. Okay, just a minute. My screen is visible?
Not yet, sir.
Okay. Just a minute, ma'am. I'm just trying to say.
No issues.
No, I hope the slides are visible.
Yes, sir. Yes, sir.
Oh, okay, fine. So let's start the session. First of all, I would like to thank Megha Madam for inviting me to have on this session on this workshop that is basically on NLP, natural language processing. So I have seen the whole schedule of the different events or different talks which are scheduled in coming lectures. So I have seen that many things are based on speech recognition or speaker verification systems. So though NLP and this speech related things, not maybe in the first instant we think that both are not related somewhere. Maybe as a newcomer or as a means like we are new to the field, but yes, both are quite connected with each other. And since many talks are lined up after related to speech recognition or speaker verification, both are talking about, they may be talking about the advanced application of a speech for recognition or speaker verification system. So before that, I would like to know that my talk I have tried to schedule in this way, so that before getting to those advanced lecture, you get a fundamental feeling of speech signal and how that might be helpful for us to understand other talks which are lined up in this workshop. Okay, so my talk will be basically focused on the very fundamental basic about understanding speech signals and how we are processing them and how we are taking out the linguistic and paralinguistic information from the speech signal, which might be helpful in NLP analysis. Okay, so that might not you can connect directly at the first instant with the NLP and then speech, but yes, understanding NLP might be very much useful before it's like with the understanding of this speech signal. So I have planned my lecture in this way. So I will mostly talking about basics of the speech signal processing. It's like their fundamentals, their origin, and how different speech or voice signal are produced from our articulatory organs, and what is their phonetics as well as acoustic characteristic. Okay, so starting with the fundamental or introduction of speech signal, or that we also call as a voice signal. So that is a nothing but a mode of communication among human beings. Speech we use to communicate with each other. So it's a nothing but it's an acoustic analog waveform, which actually carries information and produced as a sequence of sound. We can convert them into electrical waveforms using many digital hardwares, or digital devices like microphones. We can manipulate them different with the different DSP, signal processing operations, and we can again convert them into acoustic form, using speakers, headphone, or etc. That is the basic of speech signal. The basic definition. Now there always comes these two terms, audio versus speech. How both are different? Are they same? Are they different? So if we think in a generic way, then if we can differentiate between audio and speech in such a way that audio, that can be any signal which our human auditory system can perceive, like any frequency range between 20 to 20 kilohertz, that we term as the audio signal. But when we say as a sound speech, then that is specifically referred to the sound which a human being produce. Okay, so that is the fundamental difference between an audio. Sometimes we get confused between audio and speech, both are same, but both are not same. Fundamentally both are different in that way. Now as I told, speech signal processing and NLP, how they are related actually. So we have seen that uh, as I just told, that NLP and speech signal processing might not be related in the first stage. You might not see that relation. But yes, if I define NLP, that is nothing but about how a computer perceives the human language. What we are saying, or what we are writing, how accurately a computer perceive that. That is what about NLP. But uh, what we speak or what we write, that is actually that carries the linguistic information of a language. And that is very much related to or that is very much understood by the analysis or by the processing of a speech. If we understand the speech and analyzing it properly, it will help us to understand the acoustic as well as phonetic transcription of that particular language. It may help us to understand NLP or analyze NLP in a much more better way. So that is how speech signal and NLP are related. Uh, Now again, I will be stressing that how both the information, that linguistic information, which we generally focus in NLP, natural language processing. So how speech is carrying that information, or how speech might be helping us to understand that. So if we see the overall characteristic of a speech signal, it carries two types of information. Linguistic information. Linguistic means information means how we create a message. So if we start with the very fundamental a basic unit of any language, of any sound, if I can say, that is called phonemes. Using very fundamental or intrinsic sound units, that is called phoneme, we make a word. By joining different words together, we make a sentence, and that ultimately creates a message. That might be in a written format, that might be in a spoken format. So that linguistic information, that is carried out by this speech signal. And paralinguistic information, what are there? That is speaker based information, like pronunciation, age, gender. These are this speaker based information are there. Expression. So speech signal are also carries expression. Expression means by analyzing properly speech, we can have the knowledge, or we can have the information about emotion, what is the mood of the speaker, and all those informations. So these are the different so in this way we can say that the speech signal are quite informative in nature. So before after introducing a speech signal, I will now go back to a very fundamental the thing, that how a speech is generated, starting from their role, that what is a speech actually, that we have understood. Now from there, how it is being generated from our articulatory system, or when we think to say something. Let's suppose I'm trying to say hello, so this how this hello word is being created in our neural system, or from there it is coming to our auditory system, that we will try to understand. So this thing I already explained, that uh, speech as a elements, means like what are the elements in the speech communication, that we have seen that in human as well as in electrical form. Human, it act when we talk something to some other person, then there are two peoples. One is a talker, one is a listener. When we speak, that when we speak, that speech goes to the medium, to the listener. Similarly in electrical form, uh, when we try to transmit our speech or voice, it goes through some electrical media to the receiver. So in this way, this speech communication happens between the human, as well as maybe as a communication medium, electrical communication form. So this is important, that I was talking about, that how the speech signal is generated from our auditory system, from our starting from our neural system. That, like example I gave, when I am trying to say hello, that hello word is being framed in my mind, and how from thinking that I'm trying to say hello, it is coming in form of a speech. So as a talker, as listener, that like previous example I gave, there are one person act as a two role, the one is as a talker, one is as a listener. So we are having a dual role. When we see the role person role as a talker, then I am trying to say something to you. Let's suppose I'm saying, trying to say hello. That hello, when I think hello, then thinking hello and coming in form of speech or in form of voice, what are the different aspects or what different processing involves, that I'm trying to explain here. So when I say trying to say hello, that message is being framed in my mind. In my mind is thinking that yes, I have to say hello. Then whatever language I want to choose, I will choose the proper that language. Let's suppose I'm trying to say hello, so obviously hello is an English word, so I will be choosing that English word. you know so message is being framed in my mind. I have chosen the language, particular language in which I'm trying to say that word. Then that message is getting coded. Message coding is happening. What is message coding? Message coding is nothing but taking the language code of that particular language which we have selected. That a coding will get generated in our mind. That is happening up to this point, it is happening in our mind only. And those message codes then will be transmitted through neural signal uh, to some muscular commands. So here the neural and muscular command transformation, I can say, happens. And this neural signal which are getting framed in our mind get transmitted, get converted into muscular commands, and then muscular command goes to our auditory system. Auditory system means like our mouth, our tongues, our lips. These are the actually our the system which actually articulatory helps us in articulation of any word. So this muscular command received by those organs, and they produced or they act as a speech production system, and they produce the speech or the word hello. So these are the things actually involved in producing a simple word. Similarly, any word if you want to say, so such type of conversion from the neural to muscular command, and then our speech production system comes into picture, and then that produces that same thing which we are thinking in our mind. So this is actually how speech gets generated when we think to say something. That is as a talker. Now I'm coming to the listener part. When I'm listening that thing, so well, if a person saying hello to me, will I perceive hello or not? That will depend my auditory system, my hearing system. So there my role will come as a listener. So there I will take a speech. That speech will go, that is tied to our ear. That is our main part of our auditory system, or our hearing system. that have heard that someone has said something, but whether I will perceive that word hello or not, so that will depend on the how my hearing system is responding. So speech processing system will take the energy in form of obviously, until unless we have not perceived the word hello, it is in form of acoustic energy only. So acoustic vibration or energy will strike to our hearing system, that is called eardrums, and they will convert that acoustic variation to nerve impulses. Those nerve impulses will go to our brain. Now our brain will decode and perceive that someone has said hello to me. Then I will respond accordingly. So these are actually, as a talker and listener, how speech is being produced in our mind, in our production system, and how we are perceiving it through our auditory system, or our hearing system. So that actually important to understand, mainly because until unless we don't understand that thing, we may not able to appreciate the that how this linguistic information of any word or from any language that is actually being converted into either form of a speech. So coming to the next part, once we understood that how a speech is being generated, in our mind, and through our speech production system, I will trying to explain you that how our speech production system will work. So these are the different organs actually which involves in our speech production system. Each and every organ is having some role in producing some sort of a speech. So you must be very much understand means like trying to understand the importance or role of each organ. Because until unless you appreciate you understand their role, you might not appreciate the way it is affecting the speech production or but speech characteristic. Okay. So out of this nasal is like I will just once I will name them. So the nasal cavity, velum, tongue, epiglottis, vocal folds, esophagus, if spinal and this is a thyroid cord, trachea, and these are lungs and chest cavity. So out of all these organs, actually very important organ which act as a major role in speech production system is vocal folds. So you can see there's a vocal fold that is nothing but a strip-like structure here around our neck, which act as a main excitation source, in producing the speech. So what it does, I will try to understand it more properly in the coming slide, but it acts as a major role in producing a speech. Let's try to understand how. So this is in detail. I have explained the vocal folds. These are the different vocal means like organs which help us in producing a speech, and these are the vocal tract. Tract means some pipe-like structure actually which carries different speech production organs, and which helps in producing different type of speeches. Okay, so these are the number of means like organs, very minutely, means like very small organs also being listed here. These act as a our uh, articulatory system. Vocal folds, pharynx, velum, soft palates, hard palates, alveolar, rees, teeth, lips, all these are the part of our vocal tract. And in the second figure, I have shown the places of articulation. So these are actually 8 places which help, or you can say, which are having important role in uh, articulating a particular sound. They might impact the production of a particular sound. So these are we will see their role in producing different type of speech or sound. First, here we need to understand the role of different organs. So I will try to understand explain it one by one. So trying to understand the speech production mechanism. So it is speech is mostly produced when we exhale air. Obviously inhaling, while inhaling you can't produce any speech. When we exhale the air, or when air comes out from our mouth, then that helps in speech production. Our which are the major organs involved there? Our lungs and associated structure, they produce the required energy. Acoustic energy, when I'm saying energy, means I'm talking about the vibration or acoustic vibration. Vibration, if we see in other term, that is energy itself. Okay, so from the lungs, what happens? From the lungs, actually they produce the required energy. That energy, or that acoustic, I can say, wave, that from here it goes to this part, our vocal folds. So vocal fold, as I told, that plays a very important role in acting as a excitation source for different type of a speech. So when air which is filled in our this lungs, or which is being pumped from air from our lungs, that goes to this vocal folds, then vocal folds vibrate, either vibrate or constrict, either maybe partially or totally. And due to this vibration or constriction of vocal folds, we produce different type of sound. When I'm saying hello, when I'm saying hi, when I'm saying welcome, these are three different words. And in producing these three different words, my vocal fold is acting differently, and that is why I'm able to produce these different three types of different sounds. Okay, so that is was the role of the vocal fold. So in the supra glottal cavity, pharynx and oral cavity and nasal cavity. So nasal cavity is this much. If I show here, this is called, and this is a nasal cavity, this is oral cavity, and this is called pharynx, which involves multiple other organs. So these three in combine, behaves as like a time varying resonator. Okay, so in combine, if I say, then whole up to this term. So nasal cavity, oral cavity, and pharynx. So up to this part, you know it act as a time varying resonator. If I see it technically, then it is a time varying resonator. Resonator means some device which can have resonance. Resonance means in that can reach in a some different, in a specific situation, where it can maximize the outflow of something. That is called resonance in general. So our this speech production system also act as a resonator, time varying resonator. Why time varying? Because when we say something, when we produce a speech, so when when I'm saying hello this time, and after 1 second if I say again hello, there will be some changes. Both will not be exactly same. There will be some change, because I cannot put my articulatory system in the same position just 1 second before. That's a very important and very important characteristic of our articulatory system. That's why it is called time varying resonator, or time varying filter also, I can say. Okay, so that is what the a very important characteristic, and that is produce many challenges in speech processing or speech based applications also, because our vocal tract as a time varying, so it changes its time based characteristic. Okay, so now let's try to understand the speech production in a little more specific way. So as I told, that vocal fold vibrate and then um, act as a excitation source for producing different type of speech sound. So what kind of a vibration will happen, depending on the vocal fold that act as a primary source for vibration. So what can be different way, or what can be different type of vibration? So voiced excitation, unvoiced excitation, and mixed excitation. These are the three type of different excitations possible through our vocal folds. So our this vocal fold, which is here in uh, around this structure and around our neck, that act as a excitation source, and then it act in a three different way of excitation it produces, and then different excitation actually help us to produce different type of speech sound. For example, if it is vibrating uh, periodically, I should not say periodically, if it is having uh, it vibrates. Let's suppose it vibrates. Two condition arises. I told, in one case it vibrates, in second case it does not vibrate, but it constricts. It constricts at some of its along the vocal tract. So when it vibrates, vibration means something happening periodically. So when it vibrates, it produces voiced excitation, that is also called voiced speech. Voiced speech means majorly the vowels A, E, I, O, U. These are in general they are voiced speech, and they are produced due to voiced excitation of our vocal folds. Unvoiced is excitation, there is no vibration in the vocal fold. Our vocal fold will not vibrate, but it will constrict along the vocal tract, either maybe partially or completely. And that helps in producing unvoiced speech. So unvoiced speech is nothing but where no vibration happening. So if you see the major difference between voice and voice, then voiced speech will be periodic in nature, because it is being produced due to vibration of the vocal fold. It will remain unperiodic because it is not the vocal fold is not vibrating, so it will remain aperiodic. So all the consonants fall in this unvoiced range. Most of the consonant fall in unvoiced speech range. Mixed excitation, where vocal fold partially vibrate and means like rest of the things remain same. Means it's just a mixture of this voiced and voiced both. That helps to produce mixed type of sound. So we will see them with example. So voiced in so these three type of different excitation, I hope you understand. There's depending on the vibration of the vocal fold. Now, due to that, what kind of sound we produce? So vowels, as I told, they are mostly the voiced speech. So voiced speech, oral cavity is wide open, tongue up, glottal vibration. So these are the position of our different articulatory system. Your oral cavity is wide open, like for example, let's pronounce A, E, I, O, U. Mostly if we produce vowels, so you can see the connection or the sequence of these different organs. Unvoiced consonants, like I told, there's an unvoiced excitation. So in unvoiced cases, you can have vowels, means like voiced also, unvoiced also, means like consonant vibration you can have. That's why I told that unvoiced can be maybe majorly for consonants. So but here some cases you can have voiced also, means like in some consonants. I cannot generalize that for every consonant it will be unvoiced. In some consonant it is voiced also. For example, B, C, D. So if we pronounce these words, so in some words you may feel the vibration, glottal vibration. In some you may not feel vibration, only constriction you may feel. Complete constriction means complete closure. Okay, so these two type of variation may be possible. So here it is actually shown to nasal articulation and oral articulation. In the figure it is shown. So nasal, first let's try to understand the nasal sound. So nasal sound means when our nasal cavity, I told that this is the nasal cavity, our through which we breathe through our nose. So that the passage is called nasal cavity. So when this nasal cavity get coupled through this oral cavity, as you can see through arrow it is being shown. So in this condition we get a nasal sound, because nasal sound is also get coupled through oral sound. In the second figure, this is, you can say, that's a oral articulation. The nasal cavity is completely blocked through this velum part or through the last part of our palate, you can say. So here you can see that is the oral articulation. So that nasal, when nasal cavity gets coupled, that help us to produce nasal sound like m, n. It's like m and no. If you produce if we pronounce that m, n, just if you see, if you produce try to articulate this sound, we can feel there is a some sound is coming from our nasal. So that is actually nasal sounds. Fricatives, partial closure and narrow opening. When when there is a partial closure and narrow opening, like for example, let's suppose zebra when we articulate z in zebra, z, then we can see that our two articulatory means like our lips are coming close, but they're not completely close. It's a partial closure and then narrow opening. So like sitter, when we pronounce. So these type of sound are called fricatives, you know. So these are the different, depending on the position of different articulates and articulatory system, we can have these many different type of speech sounds. Understanding these speech sound technically is quite important, because once, if we not understand them, their production or their characteristic properly, we may not, the phonetic description when we give it, you know. So either we make a computer to learn those things, it will be quite difficult, you know. So that's why understanding the characteristic of the fundamental sounds which are being produced, that is quite important. Here I have I have shown uh, uh, the systematic representation of a speech production system. It's that is a physical, I can say, if I want to model my speech production system through some hardware. Okay, I want to make a hardware of my speech production system. Can we have a systematic representation? So yes, we can have it. So this is the physical or a systematic representation, which is actually uh, very close to, means like we can model it very closely to the actual our speech production system. So here in physical form it is being shown. So we can see that lungs, our lungs is being shown as a piston, where muscle force are acting enforcing, are producing some force through this piston. So our lungs actually act as a piston, full means like that is filled with air. So, okay, so our muscle forces forcing this air to to pass through this our vocal tract. Okay, when this lungs, when this air goes through this vocal tract, these are vocal folds, you can see there's a vocal fold, are two strip like a structure, which either closes that tract completely or partially, or it may a mix of these things, means a partial closure, partial opening might happen. Okay, so vocal cords act as a, you can say that stopper, or a partial stopper, means like as a valve, you can say, you know. So after that there's a pharyngeal cavity. There are other organs involved there, means like they fall in this pharyngeal cavity. You are having this tongue, you are having this means like there's a velum. This velum actually act as a close, either coupling or decoupling of this nasal cavity, and you are having this oral cavity. So depending on your velum, your nasal cavity is coupled, you produce the nose output, nasal sounds, and depending on this nasal cavity is blocked or decoupled, you produce the sound through mouth. Okay, so this is the physical structure. It might help you to understand the speech production system more properly. Okay, so you can see the role of the vocal cord. It is acting as a as a stopper of this air. So this air, how that air is getting modulated, that will help to produce different type of sound, and that control is with this vocal cords only. So that's why this vocal cord is a very important important organ in our speech production system. So that was the physical structure I just explained in the previous slide. Now coming to a technical side of it, if I want to model, um, it's like in terms of signal processing, if I talk, okay, so digital model, if I make for a speech production system, what could be the different attributes, you know, or different parameters, I can say, or different entries, entities involved. So I can very easily, if you understood so far the speech production system, it might have been quite clear that the production happens in means like your vocal cord act as a source of excitation, and which help us to modulate the waveform which go pass through our articulatory system, and which helps in production of the speech signal. So if I just see all things in a technical way, or in a digital model way, so I can have a complete model through which I can just mathematically model the speech production system. So for that I need a periodic impulses, I need a white noise, you know. These two things are required to model the vibration of a vocal cords, because when vocal cord vibrate, that produces a periodic wave. It does not vibrate, it produces just first like a structure. That's like just air, so in that case it is just looking like a noise. So these two combination of with this periodic impulses and white noise, that you can take as a excitation source, that is modeling the vibration of your vocal cord, that goes through some gain entering to our articulatory speech production system, that we have I told, that is nothing but a time varying digital filter. Okay, so when
Excuse
this
me, sir. Anurag, sir?
yeah ma'am,
Yeah.
yes ma'am.
Sir, you just complete the somewhat topic, and can we take
Yes,
a
ma'am.
break because AICT expert is joining the session?
Okay, okay, ma'am. Okay, ma'am. So
Right.
I can
And
stop right now here. So you make him to take the session, and after that we can I can complete it.
yeah, we can sum up the things. Right, sir. Yeah,
Okay,
as it is on
okay.
the national education policy, so even you also please attend it.
Yeah, sure, sure, ma'am. No,
Right,
I'm just
right,
keep enjoying.
right.
So okay, ma'am. So I'm stop sharing. I'm stopping sharing right now. So you
Yeah,
just
you just, if
complete.
you have to sum up whatever you are talking, so no
Ah,
issue.
ma'am. Yes, yes. This was
Yeah,
already.
within
I
then
yeah, okay. Just 2 minutes. I will just finish these things,
yeah,
and
yes,
then
sir, sure.
that's it. So this was I was talking about the digital model for speech production. So here that is the mathematically I can mod how I can model the speech production system I just explained. So you just take a periodic impulses, you take a white noise, you take a combination of that two through some gain that will make the excitation source or excitation and signal En, which then you can take a digital filter or time varying digital filter whose impulse response you can take Hn, so that En when passed through this digital filter, that will produce the speech signal Sn. So if I just see the whole structure together, then speech signal is nothing but that is a consequence of passing a error En signal, means like excitation signal, or that's also called error signal somewhere through some time varying digital filter, and that produces the speech signal. So through which you can mathematically model. So in terms of Fourier transform, if I see, then Sn, if it is having S omega, so S omega will be nothing but Hn into H omega into E omega, the corresponding Fourier transform or frequency domain representation. Or in time domain, if I talk, then Sn will be nothing but the convolution of your impulse response Hn and En. That is how actually any LTI system, if you remember, that is how we calculate the output of any LTI system. So that is how a speech production system you can model mathematically. Okay, so just I think I will stop here, and then we will start the discussion after this the session will the current session will end. Okay, ma'am.
Right. Thank you so much, sir.
Okay, okay.
Madam, it's our request if Dr. Anurag, if he can also be here. So if it's
Yeah,
possible for you, sir, request. Yeah.
yeah, I'm here only, ma'am. I'm here.
Okay. Thank you so much. I'm sorry for this inconvenience. Yes.
Okay, it's okay, ma'am.
So once again, good afternoon to all, and we have AICT officer with us to discuss on National Education Policy 2020. So I'm very much thankful everyone for participating in the session, and also have some thoughts regarding the new policy.
Savita ma'am, very good afternoon. This is Colonel Venkat.
Good afternoon, sir.
Good afternoon. Good afternoon.
Ma'am, just exactly give me just about 2 minutes, ma'am. I am coming online. 2 minutes, ma'am.
Okay, sir. Okay.